All right, welcome to section 1.6, solving linear inequalities. Our goals for today is I can solve simple inequalities, I can solve compound inequalities, and I should also say we can also graph these inequalities. Example number one, solving an inequality with a variable on one side. We want to solve this. We're going to solve it just like we've been solving all the other problems in class, except now we have an inequality symbol. So this will be 5y is less than 20. I'm going to divide by 5, and I get y is less than 4. Now, one thing that we do want to know how to do is we want to know what this looks like graphically. So if I put this on a number line, what I can have is something like this. Now, on my number line, if you see something like this where it is less than or greater than, it's going to be an open dot. And then what I want to do is I want to show where all the numbers are that are less than 4. So I know all the numbers that are less than 4 are to the left. Now if I do this, this gets kind of confusing because my line's not super big. So what I like to do is I like to go up and over to show that these are all my numbers that are less than 4. Let's look at letter B. So in letter B, I'm going to add 9. This gives me 22. I'm going to divide by 11, and I get 2. You'll notice that this is also a greater than sign, so it will be an open dot. And on my number line, I'm going to put an open dot, and this is saying y is greater than 2. So I'm looking for all the numbers that are greater than 2, which are going to go to the right. So I'm going to go up, and I'm going to go over. All right, let's try a little bit tougher problems. These are solving an equation with a variable on both sides. So what I want to do is I want to get the variables on the left side, the numbers on the right side. So I'm going to subtract 6x from both sides. And when I do this, this will give me negative 4x plus 1 is less than or equal to negative 1. I'm now going to subtract 1, so negative 4x is less than or equal to negative 2 divided by negative 4. So this will be negative divided by negative 4. So this on the right-hand side, negative divided by a negative is a positive. And the one thing you got to be careful about is remember when you divide by a negative sign with an inequality, our inequality sign has to change so that this now becomes a greater than or equal to. So anytime you divide by a negative number or multiply by a negative number, you have to switch this inequality sign. So we have, instead of a less than or equal to, we have greater than or equal to. Now, if we were to graph this, what we want to do is we want to go halfway between 1 and 2. We have that equal sign, that greater than or equal to, so this one is going to be a closed dot. Now I'm looking for all the numbers that are greater than 1/2, so that's going to be to the right. So that's how you graph that. Let's look at the second one. So on the second one, I want to get my x's on one side. I want to get my numbers on the other side. So I'm going to subtract 10x from both sides. This gives me negative 3x on the left side. Then I want to subtract 9 from both sides. That gives me negative 21. I'm going to divide by a negative 3. And again, I'm dividing by a negative, so my inequality sign will switch, and this will be a 7. So if I put this on a number line, I'm going to go ahead and do a closed dot because it is less than or equal to. And I'm looking for x is less than or equal to 7, which is going to go to the left. All right, let's look at a problem like this. This is solving an and compound inequality. Anytime you have an and compound equality, you'll notice how they look when we graph it. They're a lot more unique, and well, they're unique because we'll see and in an or statement. So let's take a look. Now, anytime I have something like this, what I'm going to do is I'm going to solve two inequalities at the same time. So to solve two inequalities at the same time, I'm going to get 3t, I'm going to get t by itself. So I'm first going to add 8. Now, since I added 8 here, I have an inequality here and I have an inequality here. So what I'm going to do is I'm going to add that 8 to all three parts. This becomes a 6. This is a 3t, and this becomes 18. We next want to divide by 3, so that way we get t by itself. And then what I'm going to do is divide everything by 3. So this is now a 6, and this is a 2. Now when I graph it, the unique part of this graph is that an and statement, this is a less than or equal to, so I'm going to, t is greater than or equal to 2, and t is less than or equal to 6, so these are both filled in dots. And since I'm looking for a number that is greater than 2, greater than or equal to 2, and less than or equal to 6, an and statement will come together. They will meet, and they will contain all the numbers between these two values. Let's look at the next one. Again, I'm going to solve two equations at the same time. So I'm going to subtract 4 from all three parts. This gives me negative 13 is less than t, which is less than 6. If I put this on a number line, I'm going to go to negative 13, negative 12, 10, 11, negative 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6. So that if I put this as a 6 on my number line, I know that t is less than 6, so this will be an open dot. And I know t is greater than negative 13, so that will be an open dot. And I'm looking for all the numbers that are less than 6, which is to the left. And I'm looking for all the numbers that are greater than negative 13, which are to the right. And so we have, again, that graph where the two numbers come together and meet. We have one more type of problem, which is an OR statement. An OR statement is going to look a little bit different than the AND statement. But what we're going to do is we're going to begin just by solving each of these inequalities. So there's two inequalities and they're separated by an OR statement. So I'm going to subtract 3. So 2x is less than 2. So x is less than 1. I have the OR statement, and I'm going to add 7 to both sides. So 4x is greater than 16, and x is greater than 4. So on my number line, if I'm to graph this, I have 1, 2, 3, 4. I have x is less than 1. That's an open dot, and it's going to the left. If I have x is greater than 4, that's an open dot, and the numbers that are greater than 4 are going to the right. Anytime I have an OR statement, they go away from each other. Let's look at the next one. I have two problems separated by an OR statement. So I'm going to go ahead and solve both inequalities, and then I'm going to graph them just like we did over here. So I'm going to subtract 7, so negative 2x is less than negative 4. Remember, I'm dividing by a negative, so I have to switch this sign. So this will be x, and this will be a 2. Over here, I will have 3x plus 5, so I'm going to subtract 5. That gives me negative 3. And I'm going to divide by a 3. Now, with my OR statement, I'm going to go ahead and plot these. So negative 1, 0, 1, and 2. X is greater than 2. I know that's an open dot, and I'm looking for the numbers that are greater than 2, which is to the right. This is x is less than -1, so I go to -1. It's an open dot, and I'm looking for all the numbers that are less than -1. And again, since this is an or statement, my graph, they go away from each other, and